In this video, I want to verify that this formula is a formula for the constant elasticity demand curve. So we have this equation for elasticity, and what we're going to do is we're going to figure out the elasticity of demand, the price elasticity of demand for this demand curve. So we have, I'll just plug it into this formula. We'll have epsilon equals P over Q. And then this just says, take the derivative of this demand curve with respect to P. So I'll do that. So d dP of AP to the epsilon. And what is this? That'll come out to be, this is like the power rule, A epsilon P to the epsilon minus 1. And then we'll have, I'll just bring this down, P over, and then I'm actually going to plug in for what Q is. That's just A P to the epsilon. And then let's simplify here. The A's will cancel. So I'll have P epsilon minus 1 divided by P to the epsilon. Then we'll have epsilon P to the epsilon. So, P times P to the epsilon minus 1, it's the same thing as, say, like X times X squared or something. That will be X cubed. So when you multiply things and then you have an exponent, you can add the exponents, because it would be the same as X to the 1 times X squared. Anyway, this just becomes a P to the epsilon divided by P to the epsilon. Those cancel, and we're left with just epsilon. So what we've discovered here is that this demand function here has a constant elasticity through the whole demand, through the whole curve. So if we imagine here's P, here's Q or X, it's going to look something kind of like this. And anywhere along this curve, if it says if we decrease or if we increase, let's say we increase P by 1%, we're always going to be decreasing Q by 1%. So that's the constant elasticity demand curve. And it's not just by, not by 1%, it's by epsilon %.